Hello dear learners, today we will learn about the capacitors. So you know what is a capacitor? Basically a capacitor is a energy storage device. So which type of energy a capacitor stores? It stores the electrical energy. So practically you might have seen the capacitors in your day-to-day life. You can see here in this figure that there are some few capacitors. Some are in a square shape, some are cylindrical type of. Okay, so we will see them in detail. So let's move on. So the objective of the class is to impart knowledge on basic concept of capacitor and its following aspects, like the definition of capacitor, then what is capacitor, then understanding the working of capacitor, then different type of capacitors, then various example of capacitors used in various devices. Then we will see the charging and discharging of capacitors. So our topic is subdivided into following subtopics. First subtopic is what is capacitor, then second one is what is capacitance, third one is working principle of a capacitor, then classification or types of capacitors. Then we will see the example of capacitors. Finally, the charging and discharging of capacitors. Then we will summarize the topic. Okay, so let's begin. First of all, what is capacitor? So basically capacitor is nothing but an electrical device which stores electric charge. Then how it stores charge? A capacitor consists of two conductors placed close to each other, separated by an insulator. So basically an insulator is there. Sometimes this insulator can be a dielectric material. So if there is nothing, then air will be there, or sometimes the vacuum will be there, or sometimes there will be a material. So this material will increase the capacity of storing charge because it will help in storing of the electric charge. So we will see that. Now a capacitor stores energy in form of an electrostatic field between its plates. So this is one of the important question which is being asked in examinations. How a capacitor stores energy in which form? So the energy stored is in the form of electrostatic field between the plates. Now we will see the construction of a capacitor. So basically there are two plates, two metallic plates, and in between those plates there is a dielectric material. So this is how a capacitor is constructed. In this figure you can see the upper plate is connected to the positive terminal of battery, the lower plate is connected to negative terminal of battery, and in between there is a material, that is dielectric material, and the spacing between these two plates is d meter. The area of this plate is a meter square. Okay, so this way the capacitance is, the formula for capacitance is given here, epsilon a divided by d. Okay, and this can also be written as epsilon 0 then epsilon r a divided by d. Okay, now the working principle of capacitors. So we will see how the capacitor work basically. So normally when their battery is not connected to the plates, the plates are neutral because they are having equal number of positive and negative charges by default. That means the protons and neutrons are equal in number. Protons and electrons are equal in number. Okay, now when battery is connected to this capacitor, means one plate is connected to positive terminal and the another plate is connected to negative terminal. What happens? Initially charge flows very fast and decrease is slow due to coulombic repulsion. Okay, so you understand what does this mean? Means when the, for example, the negative terminal is connected to one of the plate, so what happens? The electrons will move from the negative terminal of battery to one of the plate. So initially the plate is neutral, so what happens? The electrons will flow very fast, and make the plate negatively charged. And what happen after some time? These electrons will accumulate on the surface of this plate, and when the next electron comes, they will repel this electron. So this process will slightly decrease. Slowly, the flow of electrons will get slow down. So similar type of activity will happen at the positive plate also. The electrons will be drawn by the positive terminal of battery, and after some time, when there will be very less electrons with the positive plate, then it will not leave its electrons to go. So this way the charging process will get slowed down. Similar process happens at the time of discharging also. So this is how the charging and discharging of capacitor happens. After the full charging of capacitor, the current stops. So slowly this process is slowed down, and when the capacitor is fully charged, means it cannot hold any more charge, then the flow of charge stops. So finally we can say the current stops, and the an electric field is generated between these plates, because one plate is positively charged and another plate is negatively charged. So finally we can see that an electric field is developed between these plates, because you all know that the electric field is developed between two plates if there is a difference in charge, means one plate is positive and one plate is negative charge. So we can say that energy is stored in capacitor in form of electric field. Now we will see a video on working of capacitors.
This capacitor are electrically neutral. It means that it has an equal amount of positive as well as the negative charge. But once the voltage is applied to this capacitor, then from the top plate, the electrons or the negative charge is attracted towards the positive terminal of this battery. And through the negative terminal of the battery, the electrons are pushed towards the bottom plate of this capacitor. Now, because of the dielectric material between the two plates, the electrons which are collected at the bottom plate of this capacitor are not able to cross this barrier. And because of that, you will observe that over the period of time, the electrons will get accumulated at the bottom plate of this capacitor. So over the period of time, the top plate will have a shortage of electrons while the bottom plate will have a excessive electrons. Or we can say that the top plate will get positively charged while the bottom plate will get negatively charged. And because of the charged particles, the potential difference will get developed across the two plates. Now the building of charges across the two plates will continue till the point the potential difference that is developed across the two plates is equal to the supplied voltage. Now because of this potential difference, the electric field will get developed across the two plates, and this developed electric field is directly proportional to the potential difference, and it is inversely proportional to the distance between the two plates. So smaller the distance between the two plates, the stronger will be the electric field. So in this way, when we apply the voltage to the capacitor, then the charges are developed across the two plates of this capacitor, and because of the development of the charge, the electric field is developed between the two plates. So in this way, the capacitor stores the energy in form of this electric field. Now even if we remove this voltage source, then also the charges.
Okay, so now you would have understood the concept of the capacitor, how a capacitor work. Now we will see the various type of capacitors. Okay, so the classification of capacitor is done on various bases. So firstly, on the basis of material used, then on the basis of shapes, then on the basis of variability of the capacitance. So first of all, classification of capacitor on the basis of material used. So on the basis of the material which is used, there are different type of capacitors like air capacitor. If the air is the material between plate, then it is called air capacitor. If the paper is the material, it will be called paper capacitor. Some of the capacitors are having mica as a dielectric material between its plates, so it is called mica capacitor. Some of the capacitors are using ceramic as a dielectric material, so they are called ceramic capacitors. And some of the capacitors are having electrolyte between its plate, so they are called electrolytic capacitors. Now on the basis of shape, there are capacitors in various shapes. So first one is the parallel plate capacitor, a capacitor in which the two plates are parallel to each other, it is called parallel plate capacitor. Then circular plate capacitor, if these plates are not square or rectangular, they are in shape of circles. Okay, they are round plates kept parallel to each other, they are called circular plate capacitor. Then spherical capacitor, if these plates are in the form of balls or spheres, concentric spheres, one sphere is placed inside and another sphere is placed on outside of this, then it is called spherical capacitor. Then cylindrical capacitor, in the case of cylindrical capacitor, two concentric cylinders are there, one small and one bigger one. Okay, so this way there are four type of capacitors on the basis of shape: parallel plate capacitor, circular plate capacitor, spherical capacitor and cylindrical capacitor. Then classification of capacitors on the basis of shape, you can see different shapes of capacitors. In the first figure you can see, here it is a parallel plate capacitor. So you can see here one plate is this one, another plate is this one, and a dielectric material is placed between these. And circular plate capacitor, one circular plate is this, another one is this, and in between a dielectric is there. And the spherical capacitor, you can see here R1 and R2 is written, means this one is smaller sphere which is having a radius of R1, and this one is a bigger sphere which is having a radius of R2. Okay, and here you can see the cylindrical capacitor in which two cylinders are there and in between a dielectric medium is there. So this is a cylindrical capacitor. Now classification of capacitor on the basis of variability of value. So you might have seen that some of the capacitors are having a knob by which you can change its value. So if you can change the value of a capacitor, it is called variable capacitor. And if you do not change or you cannot change the value of a capacitor, then it is called fixed capacitor. So basically the value of the capacitance or the capacitor is changed by varying the distance between the plates. So one of the plate is moved closer or far from one plate, okay, or you can say another plate. So this way the capacitance is varied. So in this figure you can very well, see, this this is a variable capacitor in which there is a screw type of structure is there. So with the help of screwdriver you can change, you can rotate it, and hence the distance between the plate will get changed and the value of capacitor will change. So this is a variable capacitor, whereas these capacitors are fixed capacitors. Okay, learners, so you might have learned about the various type of capacitors and the working of capacitor. Now we will see the example of capacitors. Okay, so the circuits in which the capacitors are used. So computer RAM memory and keyboards, they are having various capacitors. In this figure also you can see where various capacitors are mounted on a PCB or a motherboard, you can see. Okay, PCB is a printed circuit board, right? So computer RAM memory and keyboards are having capacitors. Then electronic flashes for cameras. Okay, so the flashes in cameras, the electronic flashes are using capacitors. So what happens? First the capacitor is fully charged and it gets discharged very fast, and the load here is a valve that is called flash. So when you press the button of a camera, then the charged capacitor gets discharged very fast. Okay, through a flash, or you can say a type of bulb, right? Now the electronic power surge protectors. So there are some electronic power surge protectors. So what happens when a high power comes to your electronic device? What happens? The excess of the power gets earthed through this capacitor. Okay, so this way they protect your electronic device. Then a radio and electronic circuits. So in case of radios and electronic circuits, when you have seen in a radio there is a you can say a knob. So when you move or rotate the knob, then a radio catches different stations. So basically there is a LC circuit. Okay, so which is tuned. So in this case the L is fixed and the capacitance gets changed. So finally the LC tuned circuit gets tuned to another frequency. So in this way you are using capacitor in case of radios. And fans also you might have seen a capacitor. Okay, so here the capacitor changes phase of the electricity. So this way your fan rotates. Then motors are also having the capacitor for the same purpose. Then in TV there are capacitors. Mobile chargers are having capacitors. Okay, there are filter circuits, various filter circuits which are using capacitors. Okay, then in UPS also and in inverters also the capacitors are used. Okay, in rectifiers and filter circuits they are used. So in case of inverters, what they does, they convert one type of electricity, we say AC into DC or DC into AC. Okay, so in case of inverters a DC is converted into AC. So various type of capacitors are used there. So in this way we can summarize that topic. What are capacitors? Capacitors are basically energy storage devices. Capacitors are essential components of any circuits. Capacitors are classified on the basis of shape, material and variability. Then the capacitors can be connected in parallel or series. Okay, so this was all about capacitors. Thank you for watching the video.